Good morning, everyone. I'm Shota Olusegun. This morning, I want us to look at time energy wave model versus space-time model. Well, there's something I discovered about Einstein discovery. I discovered that the margin of space and time is wrong. Well, actually, I respect Einstein a lot. I value Einstein a lot. He has made a lot of contribution to the world of science. But from my discovery, I could see the lapses in space-time merging, and so I want us to explore it. Now, before we go deep into this, I want us to, briefly look at math, like mathematics. Well, I'm not a mathematics genius, anyways, but I think mathematics is given because there was a time I posted on Quora if mathematics was invented or being realized or so. Now I realize that mathematics is given just like the other languages that we have. Well, I will call mathematics a language of creation because right from the onset, right from the emanation of maths, it has been modeling the reality of physics, the reality of the universe itself, but people don't pay attention. For instance, starting with the number system, you see that when we have 1 plus 1, that is equal to 2, then you can have that progression like that. So that is synonymous to a person walking. And then we come up with the inverse of plus, which is minus. So minus, when you say 1 minus 1, then you know that you have 0. But from the plus, you only have 1 plus 1 starting from 2. It is not starting from 0. So the negative, which is the inverse version of plus, then gives us 0 for us to know that 0 exists. Then we as well have the multiplication, which could be synonymous to somebody running. And then we have inverse of that, which is division. And we see that division as well is doing something that is different. So when you say 1 divided by 1, you have 1. When you say 1 divided by 2, you have half, which is going deep, deep, deep into the 1 itself. It's actually narrowing it down. So all these phenomena, we have them in physics, and they actually, illustrate the reality of universe. And from there, we could see that what the plus is doing is quite different from what the minus is doing. And same way, what we have in classical mechanics is different from what we have in quantum mechanics. Now, what we have in classical mechanics is an inverse of what we have in quantum mechanics, and I've been trying to prove that right from the beginning of the series of videos I've been doing. But now we want to look at the difference between time energy wave model and space-time model. In this video, we will see which of these two, we'll see which of them is able to actually model the reality of universe the way it should. So now, let us start with space-time itself. Right from my own intuition, I believe that time cannot relativize space. Time, if time must relativize anything, it has to be energy. So this is where Einstein is wrong. Einstein is making time to relativize space, and that is not illustrating the reality of uh, space expansion or the space itself as it may be. So now let's look at this. If the entirety of 3D space is compressed and we have it in this x-axis, and then we have time on this y-axis, while we have the space, the whole of 3D space is being compressed, and we have it on this x-axis relative to this y-axis of time. Now look at this. Look at these actions now. When time stretches upward, then by the entanglement of space to time, then space will be contracted inward towards 0 point. Now, how can this model the expansion of space? This is not modeling the expansion of space in any way. Now, time stretches, or let's say time scales wide. Then instead for the space, because when time is wide, then the space interval has to be wide as well, but in this case it gets contracted towards the 0 point. You can see that divergence in the agreement of the two. And then when we look at this scenario, here we have space being stretched. Space itself is being stretched, and then instead for time to stretch as well to illustrate the expansion, we have time being contracted towards 0 point right here. So now when we look at this situation, this kind of situation is synonymous to the discrete nature of quantum mechanics. So in this, we can say we have disconnection, or we have discontinuity of what this is meant to illustrate, as in form of the expansion of space itself. But if we look at this time energy wave model, we can see that this illustrates the expansion the way it ought to be, and apart from that, it even illustrates the phenomena of quantum mechanics. So now, when time scales wide, here we have the scaling of energy to be narrow. So when energy scales narrow like this relative to time, that is an indication of expanded space, just as what we have here. And then the space is not an empty space as we know, it is just an ambient of energy. So we can see the stretch and we can see the expansion of space as it ought to be. Then another thing we need to know is that the symmetric nature of our space as we have it in parity, and then the time reversal symmetry that we are so conversant with, there is something we need to know. Because when we're talking about symmetry, we're saying that we're saying that both sides are equal, that they are the same. That's what symmetry is all about. But as you have already known, the application of formula of everything extend and even stretches energy beyond the limit threshold, and as a result of that, we have spontaneous symmetry breaking. So it breaks that rule of symmetry to have asymmetric nature of universe. But what I want you to know is that even though as this space is expanding based on the relativistic scaling of time to energy, what we have in the classical mechanics is different from what we have in quantum mechanics, even by initiating the symmetric nature of a wave polarization of time energy wave. What they are doing is different from each other. Now, this is the wave magnitude, where we have 5.7 times 10 raised power 48 for classical mechanics, and then we have 5.7 times 10 raised power minus 48 for quantum mechanics. Now, here we see that as time expands towards the maximum 0 point, if we supply this in the formula of everything, we're going to get this mass worth for this classical mass value, and that is 1.4 times 10 raised power 88. But for the quantum mechanics, when we supply this value, this wave magnitude value into the formula of everything, we have 0.0000000014. Now you can see that this value is so tiny, and so the value is so small, very small compared to what we have in classical mechanics. So they are actually doing different things. So it's as if the space in this region is expanding. Why this, even though it's expanding relative to this time scaling, it's contracting to half, because there is a kind of compression right here. So that compression is what implements or even activates this symmetric nature of the time energy wave that we have. And once it is being extended beyond that, we will get the actual value of electron, which is 9.109 times 10 raised power minus 31. So we need to know that even though it seems as if it is symmetric in nature, in real sense, it is not symmetric. So the whole uncertainty principle, I think it's based on that compression of the polarization effect of time energy wave model. So what we have could be likened to illusion. It could be likened to illusion. So now let's try and see how it works as a time or as time energy wave model. Now, if somebody should be on this mass, now when that person can view right from where he is like this, then what he will see is that he will see the symmetric nature of the past and the future into the singularity of black hole as we have it here. This is the evolutionary singularity, and this is the black hole singularity. So the person right on top of this mass will see symmetric nature of the curvature into the singularity of the evolutionary singularity, and then the curvature into the black hole singularity. But now the question is, are they really symmetric? Are they really symmetric? So this is how we need to analyze this to get the real fact. Now, if for instance we say we have line like this, that is, when it gets to the maximum point as it travels like that, we have this vertical line that then eventually lines up to show the curvature. So now these lines that we have, we can just tag them or classify them as the quantized measure of the quantum mechanics. So now the person viewing from here, from this point, will be able to see that discrete nature of quantum mechanics, because there is this connectivity from the trajectory to form smoothness that will emerge the convergence of mass. Because what this person is seeing is not the reality. So if the person should travel as the event unfolds, if the person should travel along as the event unfolds, then the person would see that then the person will see that the whole thing is disconnecting from this point. It will disconnect back into the singularity, just as we will have it in this singularity, in the trajectory of singularity of black hole. It will be like that. Why? Because the person is in a place that is so wide, and so the level of energy at this point is different from the level of energy at quantum realm. So relativistically, the person will be able to just relate it as it will be in quantum realm, because the the relativity effect will let us have the discontinuous nature of the quantum realm relative to the classical as the person view the whole event. So then the person will be able to see it, and it will be as if what we have in the space-time analogy. So there will be discontinuity in the trajectory as it goes into the black and into the singularity. But if the person should be here, and the person from here will see as the whole thing expand, and if the person should travel along as the event unfolds, then the person will actually see the smoothness of the trajectory as it goes towards the zero maximal point, and then you'll be able to see the convergence of the mass to have this mass worth. So we have what is known as speed difference factor, just as I have said in the previous video. That speed difference is what relativity effect is implementing. So when you look at a relativity effect, you see time dilation in relation to length contraction. That is what we see. But before we can get actual real value, then it has to travel beyond the limit of this symmetric nature to arrive at asymmetric nature of the universe. And that is what the formula of everything has actually done for us. That's what it has done for us, and we thank God for that. So now I want to actually I want to quickly associate this with Doppler effect. Doppler effect. Now when we look at Doppler effect, you see that when you have a light of a particle approaching you, then the front side of the particle will get contracted as it approaches you. So, but if that particle is traveling away from you, then you will see the red shift. You will see the red shift. So what I'm saying is, if a particle traveling away from you, the effect of the light will be in red shift trajectory. While particle approaching you will have its own effect of the light to be in blue shift. Now what is that? What is that telling us? That is telling us that the way space is being contracted or being expanded are not the same. That the operation of the contraction and that of the dilated effect of the redshift, they are not the same at all. So in that sense, what we see is that the person that will be on this spot would see the redshift, and by seeing the redshift, you are actually seeing the expansion, and that expansion of time energy wave interaction, that gives you the past. It gives you the past trajectory, and that is what actually makes the past to be different from the future. It gives you the past trajectory. But the blue shift that you have, that is the contraction of time space, time energy wave interaction that would let you have that is telling you that that is the future. So that is actually telling you that the trajectory is going towards future, and that trajectory of the redshift is going towards the past. So from the Doppler effect, we can get to know the difference between the past and the future, and then we can get to know the difference between the classical mechanics and quantum mechanics. Don't forget that quantum mechanics is an inverse of classical mechanics. So as time is scaling wide relative to energy, energy is being contracted in such a way to effect the speed difference that we energize phenomena at quantum realm relative to the classical realm. And that is how the effect of balance will be in place. So we should always know this, and it is, of course, it's a novel discovery, and I'm going to put the link to that research publication in the description below. You can actually visit that and explore it to confirm all these values that we have on board. So that being said, please like this video, share it with your friends, then you make sure you subscribe to this channel so as to be notified for the subsequent videos. Then make sure you comment, let me know your view on this. God bless you. See you next time.